Hi, this video demonstrates the use of OpenStack ESI for installing an OpenShift cluster using the OpenShift Assisted Installer as a tenant user. In this demo, we'll walk through the process of configuring our leased nodes for installation on a private network using the OpenShift Assisted Installer. Then we'll use external flowing IPs to give external access to the cluster's API and ingress IPs on the private network. Finally, we'll demonstrate how we can lease an additional node through OpenStack ESI and add that node to our OpenShift cluster as a worker node. If you'd like to try this demo yourself, you'll just need an OpenStack ESI installation with a tenant user that has 3 leased nodes to start, as well as a private neutron network configured for external access. You'll also need access to the OpenShift Assisted Installer. In this demo, we use the one at https://console.redhat.com. Another useful but optional package is Python ESI client, which adds useful CLI commands. Finally, you may want additional leased nodes if you would like to add additional worker nodes to the cluster. In the first part of this demo, our tenant user will use the OpenShift Assisted Installer to configure their OpenShift cluster. Then they'll configure the leased nodes and kick off deployment. Next, they'll update the internal DNS server on the private network. And finally, they'll create external floating IPs to give external access to the cluster's API and ingress IPs on the private network. Let's begin with the OpenShift Assisted Installer. We'll start at https://console.redhat.com under OpenShift Clusters and navigate to the OpenShift Assisted Installer by clicking on Create Cluster, then Data Center, then the Create Cluster button in the Assisted Installer section. This brings us to a multi-step wizard. Let's fill in our cluster's name and domain and then move forward to the third step, host discovery. During this step, the installer will need to discover the nodes for our cluster. Clicking on Add Host will allow us to create an image that enables that. First, we'll upload our public SSH key. Then we'll create a discovery image and copy the URL. After that, we simply have to configure our leased nodes to boot from that image. We do so with a few steps. For each node, we set the deploy interface to RAM disk. Then we set the node's boot ISO to the image URL provided by the installer. This URL is secret, so in this video I'll use a fake URL and then correct it behind the scenes. The third step is to connect the node to the provisioning network. This is needed for provisioning. We'll move them to our private network later. We'll use the command OpenStack ESI node network attach, a convenient command from Python ESI client. Once all the nodes have been attached to the provisioning network, we can run OpenStack ESI node network list to verify our node's network status. Now we can deploy the nodes using OpenStack bare metal node deploy. Deployment takes a while, so we'll fast forward in time. We know that the nodes are ready when they appear in the wizard. And here they are. Let's move to the second to last step in the wizard, where we configure the networking. Here we select the subnet, but the only available subnet is for the provisioning network and not our private network. To remediate that, we'll use the CLI to detach our nodes from the provisioning network and attach them to our private network. Once again, the Python ESI client provides CLI commands to make this easy. OpenStack ESI node network detach, which takes as a parameter the port for the node. After all 3 nodes are detached from the provisioning network, we'll attach them to our private network using OpenStack ESI node network attach. Then, as a final step, we'll also configure our nodes to boot from disk using OpenStack bare metal node boot device set. With that done, we just have to go back a few steps in the wizard and wait for the installer to note the network change and ready the nodes. Once that's done, we can return to the networking step of the installation. Now we can see that the available subnet has changed to our private networks. We'll fill in the rest of the parameters. For the API and ingress IPs, we'll pick two IPs that are outside of our subnet's allocation range. We'll use them later. Once all that is done, we can move to the review step of the wizard. And now we can start an installation by clicking on the Install Cluster button. Installation takes a considerable amount of time, so in the meantime, we'll do some additional setup. If we run OpenStack ESI node network list, we'll notice that there are actually 4 nodes. The 4th node is our private DNS server for our private network. So we're just going to log in, and we'll update our DNS for the API and ingress IPs that we set previously. And now we'll just fast forward to the end of our OpenShift cluster installation. Now we're going to configure our OpenShift cluster so that we can access it from an external network. In order to do that, we're going to create 2 floating IPs on our external network, one for our API IP and one for the ingress IP. Next, we'll create a neutron port on our private network with an IP that corresponds to the API IP. Then we can assign one of the external floating IPs to this neutron port. Then we'll do all of that again, except this time for the ingress IP. With all of this done, we can now use these external floating IPs to access our cluster's API and ingress IPs. I'm going to update a local DNS server to these external floating IPs. And now we can access our cluster's console through the public internet, like so. In the second part of this demo, we'll have the admin lease additional node to the tenant user. Then the tenant will use the OpenShift Assisted Installer to add additional worker nodes, configure the leased nodes and kick off deployment, and finally use the OpenShift Cluster console to approve CSRs for the new worker nodes. Let's start with the admin user. As the admin user, we'll run OpenStack ESI node list to identify a free node we can lease to our tenant user. Then we'll lease a node, OCT 412, to the tenant user. When we switch to the tenant user, we can see that they now have access to OCT 412. Now we can start the process of adding a worker node to our cluster through the OpenShift Assisted Installer. By clicking on the Add Host tab, we come to the page that allows us to create a discovery image for nodes that we wish to add as a worker node. The overall process is extremely similar to the installation workflow. We specify a SSH key and create a discovery image, recording the URL as we do so. Then we use the CLI to configure the node to boot from that image. First, we set the deploy interface to RAM disk. Then we set the image URL. And finally, we attach the node to the provisioning network. Again, we can run OpenStack ESI node network list to verify our node's network status. With everything ready, we can run OpenStack bare metal node deploy OCT 412. Again, this process will take a while, so we'll fast forward to when it's complete. And here it is, except wait, there's an issue. The node status is insufficient. That's because the node is still on the provisioning network instead of the private network where our cluster resides. Let's fix that using Python ESI client commands. First, OpenStack ESI node network detach OCT 412 from its current port. And then OpenStack ESI node network attach, specifying our private network. We'll also set the node boot device to disk. And now, if we run OpenStack ESI node network list, we'll see that all of our nodes are on our private Tzu-Mainn network. However, unlike during cluster installation, the Assisted Installer will not automatically detect this network change. In order for this workflow to continue, we'll need to log onto the node. We'll do so by creating the external floating IP. Then we'll associate the external IP with the node's port in order to SSH onto the node. If we run OpenStack ESI node network list, we can see the external floating IP associated with OCT 412. We'll SSH onto the node, and then we'll restart the relevant startup container by running podman container restart next step runner. With that done, we just have to wait for a little bit longer. Then, the node will show up on the Assisted Installer as ready, and we can start the actual installation process. We'll fast forward through this until we reach the end. Now the node is ready, but there's one last thing we need to do: approve its CSRs. We do that by going to the cluster console and then navigating to compute and then nodes. We can now approve 2 CSRs. And once that's done, our worker node is ready for use. That concludes this demonstration.